Hi dear children, welcome to today's class. Today we are going to discuss exercise 13.2. First question. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So in this question, we have combination of figures. One is cone and the second one is hemisphere. A solid is in the shape of a cone standing on a hemisphere. So the base portion, that is a hemisphere, and on the top of this hemisphere we have one cone. Okay, so this is the shape of our solid, and it is given that the radius of this cone and the hemisphere, that is equal to 1 centimeter, and the height of the cone is equal to its radius. Height of the cone is equal to its radius. So thus height, that is equal to 1 centimeter. This is also 1 centimeter because that is the radius of our hemisphere. Now we need to find the volume of the solid in terms of pi. So this volume of the solid, that is equal to volume of the solid, that is equal to volume of the hemisphere plus volume of the cone. Volume of the solid is equal to volume of the hemisphere plus volume of the cone. What is the volume of the hemisphere? Volume of the hemisphere, the formula, that is 2 by 3 pi r cube. Okay, 2 by 3 pi r cube, that is the volume of the hemisphere. The volume of the cone, that is 1 by 3 pi r square h. Volume of the hemisphere is 2 by 3 pi r cube and volume of the cone, that is 1 by 3 pi r square h. Now just substitute the values. 2 by 3 pi into the radius is 1, so 1 cube, plus 1 by 3 pi into radius of the cone, that is 1, and the height of the cone, that is also 1. This is equal to 2 by 3 pi plus 1 by 3 pi, that is equal to pi centimeter cube. Pi centimeter cube, that is the volume of our solid. Now second question. In second question also we have the combination of figures. Rachel, an engineering student, was asked to make a model shaped like a cylinder with the two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rachel made. So in this question we have cone and cylinder. So the center portion, that is a cylinder, and the ends we have cone. Okay. So the center portion we have one cylinder. On both the ends we have cone. Okay. On both the ends okay, this is the shape of a solid. Now it is given that the diameter of the model is 3 cm. The diameter of this model, this is 3 cm. If diameter is 3 cm, then we will get the radius is equal to 1.5 cm. So radius of cylinder is equal to 1.5 cm and the radius of the cone, that is also is equal to 1.5 centimeter. Okay. Now, height of the cone is also given. If each cone has a height of 2 centimeter, so the height of the cone is equal to 2 centimeter. Okay. So this height, this is 2 centimeter and this is also 2 centimeter. And length of that shape is given. The total length is 12 centimeter. This total length, okay, this is 12 centimeter. Then what will be the height of our cylindrical portion? Okay, total height is given, that is 12 centimeter, and the height of the cone, that is also given, that is 2 centimeter. Then what will be the height of the cylindrical portion? This is our cylindrical portion, and if we want to get the height of the cylindrical portion, we need to exclude the height of these two cones from the total height or from the total length. So height of the cylindrical portion, that is actually 12 minus height of the first cone and the height of the second cone, that is 12 minus 4 is equal to 8 centimeter. So the height of the cylindrical portion, that is equal to 8 centimeter. Now the volume of the model, that is actually the volume. Okay, suppose it is first portion, this is second portion and this is third portion. Volume of first cone plus volume of cylinder plus volume of third cone. Okay, so volume of first cone plus volume of cylinder plus volume of the third portion. Okay, that is the volume of our model. Now volume of a cone, the formula, that is 1 by 3 pi r square h. 1 by 3 pi r square h. The volume of the cylinder, that is pi r square h. Volume of the cylinder, that is pi r square h. Again we have the cone, so 1 by 3 pi r square h. 1 by 3 pi r square h. Now this is equal to 1 by 3 pi into the radius of the cone, that is 1.5 all square into height of the cone 2 plus pi into radius is 1.5 all square, the height of the cylinder, that is 8 plus 1 by 3 into pi into 1.5 all square into 2. 1.5 all square into 2. This we will get it as 21 pi. Okay, this we will get it as 21 pi. And now we need to substitute the value of pi, that is 21 into 22 by 7. 21 into 22 by 7, that is equal to 66 centimeter square. Centimeter cube, 66 centimeter cube. Hence the volume of the air contained in the model that Rachel made is 66 centimeter cube. Third question, that is very important question. A gulab jam contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jams, each shaped like a cylinder with two hemispherical ends, with length 5 cm and diameter 2.8 cm. So the shape of our gulab jam is given. gulab jam, we have one cylindrical portion. This is our cylindrical portion, and cylindrical portion with hemispherical ends. Cylindrical portion with hemispherical ends. This is the shape of our gulab jam, and it is given that the length is 5 centimeter. Okay, the length of this gulab jam, this is 5 centimeter, that is given in the question, and the diameter is 2.8 centimeter. So this is 2.8 centimeter. The diameter is 2.8 centimeter. Then the radius is 1.4 centimeter. Then the radius is 1.4 centimeter. Then this is also 1.4 centimeter because that is the radius of our hemisphere, and this is also 1.4 centimeter. Now, what is the height of our cylindrical portion? The total length is given, that is 5 centimeter, and we know that the height of the cylindrical portion is actually 5 centimeter minus the height or the radius of the first hemisphere and the radius of the second hemisphere. So we will write the radius of the hemisphere that is 1.4 centimeter, and radius of the cylinder, that is also 1.4 centimeter, and height of the cylinder we need to take, that is the height of the cylindrical portion is equal to 5 minus 1.4 plus 1.4. 5 minus 1.4 plus 1.4, that is 5 minus 2.8. 5 minus 2.8, that is equal to 2.2 centimeter. So the height of the cylindrical portion, that is equal to 2.2 centimeter. Now, volume of one gulab jam. We need to find out the volume of this shape, that is volume of one gulab jam is equal to, here we have the combinations of figures, that is volume of volume of one hemisphere, volume of one hemisphere plus volume of cylinder plus volume of other hemispherical end. This is the volume of one gulab jam, and volume of hemisphere, okay, that is 2 by 3 pi r cube plus volume of the cylinder, that is pi r square h, plus volume of the second one is 2 by 3 pi r cube. Okay, and this we can write it as 2 by 3 pi r cube plus 2 by 3 pi r cube we have, that we can write it as 4 by 3 pi r cube. 4 by 3 pi r cube plus pi r square h. 4 by 3 pi r cube plus pi r square h. In this, pi r square is common, just take it outside. Then the first term 4r by 3 will remain, and the second term h will remain. This is pi r square into, just take the LCM, that is 4r plus 3h divided by 3. 4r plus 3h divided by 3. Now just substitute the values. That is, the radius is 1.4. So pi into 1.4 all square into 4 into 1.4 plus 3 into the height of that portion is 2. Cylinder is 2.2 divided by 3. Okay, and thus we will get it as 22 into 1.5 into 7 by 5 into 61 by 5 into 1 by 3 we will get. 22 into 1.5 into 7 by 5 into 61 by 5 into 1 by 3 we will get. This is the volume of one gulab jam. Okay, this is the volume of 1 gulab jam. Then what will be the volume of 45 gulab jam? 45 gulab jam, that is 45 into 22 into 1 by 5 into 7 by 5 into 61 by 5 into 1 by 3. We will get 45 gulab jam volume. And it is given that a gulab jam contains sugar syrup up to 30% of its volume. A gulab jam contains sugar syrup up to 35% of its volume. So, the volume of syrup in these 45 gulab jams, volume of syrup in this 45 gulab jam, that is equal to, okay, thus we will get it as 66 into 427 divided by 25 we will get. That is the volume of 45 gulab jams. Then this is 66 into 427 divided by 25 into, because 30%, that is 30 divided by 100. It is equal to 338.184 centimeter cube. Approximately 338 centimeter cube. Okay, so this is the volume of syrup in this 45 gulab jams. Volume of syrup in these 45 gulab jams. Fourth question. In that fourth question, a pen stand made of wood is in the shape of a cuboid with 4 conical depressions. Okay, so we have one cuboid, and in that cuboid we have 4 conical depressions. The dimensions of the cuboids are 15 centimeter, 10 centimeter and 3.5 centimeter. 15 centimeter, 10 centimeter and 3.5 centimeter. So the LBH is given in the question. L is equal to 15 centimeter, B is equal to 10 centimeter and H is equal to, L is equal to 15 centimeter, B is equal to 10 centimeter and H is equal to 3.5 centimeter. And we have 4 conical depressions and the radius of each is 0.5 centimeter. Okay, the radius of each is 0.5 centimeter. The depth is 1.4 centimeter. Okay, depth is also given, that is depth means height is 1.4 centimeter. Now we need to find the volume of the wood in the entire stand. We need to find the volume of wood in the entire stand. Okay, so that is actually volume of the wood in the entire stand is equal to volume of cuboid. Okay, volume of cuboid minus volume of conical depressions. Okay, volume of cuboid minus volume of conical depressions, that is the volume of wood. And this volume of cuboid is LBH minus the conical depression. The volume of con is 1 by 3 pi r square h, and here we have 4 conical depressions. So 4 into, okay, this we can rewrite it as 4 into volume of conical depressions, because we have 4 conical depressions. And this is equal to 15 into 10 into 3.5 minus 4 by 3 pi into the radius is 0.5 all square into 1.4. Okay, that we will get it as 525 minus 1.47. This is equal to 523.53 centimeter cube approximately. 523.53 centimeter cube.